Okay, let us continue with some more applications of vectors. Here we have a situation that we got some people flying some drones, and the drones happen to be flying at a constant speed. And we have one drone starts first and takes a path given by the vector equation seen. And then we have another one that starts from a different path or from 3 seconds later and takes a slightly different path. Right. So to understand what we have here, essentially this is a coordinate point, right? And here is another coordinate point. And remember, we want to be able to understand that the initial position for this first drone is 2 in the x direction, -3 in the y direction, and then usually the z direction is your altitude, and so essentially that's saying that the drone starts on the ground, right, and then travels in the negative x direction, positive y direction, and positive z direction, right, and then R2 starts, right, 6 units essentially to the left of the other drone. It starts, looks to be 5 units in front of the other drone, but also starts on the ground, right? And then we have a different parameter, and this particular drone starts in the similar x direction, but change the y direction is a different movement, and the z direction looks to be moving faster in the upward direction and moving faster in the y, let's say front back direction as well. All right, so all the distances are given in meters and the times in seconds. Determine the distance between the two drones just before Ida's drone starts, right? So after 3 seconds, Ida's drone starts. So we need to figure out R1's position at t equals 3. And R1's position at t equals 3 is going to be, right, 2 minus 3 times 2 minus 2 times 3, and -3 plus 3 times 3, and 0 plus 4 times 3. All right, and so that new position is going to be, and you should be able to do this without a calculator, but if you want to use a calculator, right, 2 minus 6, that's going to be -4. Then -2 plus 9, that's going to be 7. And then 0 plus 12, that's going to be 12. And so I'm trying to figure out the distance between. So I have -4, 7, 12 for one drone, and my other drone is at its initial starting position, which is -4, 2, 0. And so if we consider our distance, right, that distance is going to be given by the square root of the difference between -4 and 4. That's going to be 0. The distance between 7 and 2, that's going to be 5 squared. The difference between 12 and 0, that's going to be 144, right? And if we look to that, that's going to be the square root of, let's see, 25 plus 144. That's 169, and that would give us about 13 meters. But let's see where we may have made a mistake in our computation, because it seems to be that we were supposed to be at 12.6 meters. So let's check out to see if we can find our mistake. Okay, so like I said, we know that we made a mistake because we're expecting the answer to be 12.6. And if we look, it looks to be that our mistake came from that value right there. That should not have been -2. It should actually have been -3. So this number, right, should be 6, which means that this number here should be 16, and that this number here should be 160. And if we look at the square root of 160, that gives us that approximately 12.6 meters. So they're about 12.6 meters apart. Okay, now the drones will collide. We are told this. The drones are going to collide, so they're going to be in the same location at the same time, and we want the altitude where the drones collide, which is going to be based on the z direction. So we need to set up our system of equations that these two are going to be at the same location, the two drones are. So let's go ahead and set up our system that we know that 2 minus 2t must be equal to negative 4 minus 2s, and negative 3 plus 3t must be equal to 2 plus 4t, and 0 plus 4t. Whoop, this should be an s. I want to make sure we keep our parameters correctly. So 0 plus 4t needs to be equal to 0 plus 7s. If we come to solve our system, all right, let's go ahead and put in our piece. So we have 2 minus 2, right? And if I want to keep the same variable, I can use. So that's going to be equal to negative 4 minus 2s, right? So then my next equation is negative 3 plus 3, right? And I could have my t that way. And 2 plus 4 alpha s, right? And let's add one more equation, which is 0 plus 4t, right? Let's go to t, and that needs to be equal to 0 plus 7 alpha s. All right, so we have our three equations. We look to solve our system, and the solution at s equals 4 and t equals 7. So essentially, we've got after 7 total seconds, or after the second drone is up in the air for 4 seconds, but we want the altitude, and so we need 7 times 4, and that's going to be 28 meters, where we see the altitude of 28 meters. So that's an example of working with vectors in an application setting. We'll do one more example talking about boats, but recognize that the only way that I collide is if I'm at the same place at the same time. How do I know from this information that they are at the same place at the same time? Well, look at my parameters. S equals 4 and t equals 7, but I know that t is s plus 3, so therefore we're at the same place at the same time, right? Which means we're going to have a collision, all right? Make sure you stick around, ask questions for clarification, watch additional videos where needed. Thank you for your time.